Hey there, welcome to this particular session where we are going to talk about fault tolerance and circuit breaking. So when it comes to building microservices, having technical glitches is a norm. Not only in microservices, but in any of your software projects, right? It's a norm. Now, having technical glitches is a norm, but how would you handle them? Handling them is really important. And that is what we are going to talk about in this particular session. So if you are new to this session and if you are watching my videos for the first time, I would highly recommend that you get a sense of the previous videos as well. So just to let you know, this particular video is a part of a series whose link you'll find in the description of this video. So if you want to get some context into the source code that I have used, you should 100% watch the earlier videos as well. Now, let's talk about what we are going to cover. So like I mentioned, this session is going to be about fault tolerance and circuit breaking. We are going to talk about how we can add resilience to our microservices, and we will talk about things like how we can integrate Resilience4J, how we can do circuit breaking, how you can manage faults and downtimes even better. So we will implement things like rate limiting, fallback, retries, and so on. And we will do this in a hands-on way. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so, because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video, and turn on the bell notifications. Also feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Hey there, welcome to this class. So let us start talking about fault tolerance and understand what it is and why is it important when it comes to microservices. So in distributed microservices, there will be scenarios where something or the other fails. And it's really important to manage these failures. And this is where fault tolerance comes into picture. So what is fault tolerance? So fault tolerance can be defined as the ability of a network or a system to continue operating without any interruption. So this is what fault tolerance means. Now, the question is, why does this matter much to microservices? So in microservices world, we have different systems. So it's a distributed system where each service is running on its own, and there is a possibility that one service might fail. So there are three microservices, as you can see over here, and it's part of an architecture. And to outside world, it is one single application. It is not three different systems. It's just single system that exists. Now, what happens is usually these microservices will be communicating with each other. And in such scenarios, there can be possibilities that one service fails. So let's say microservice 2 fails. Now, because of that, all the calls that would go to microservice 2 would fail. And this would result in entire system collapse, which is not good. So this means that our network is not fault tolerant. So if something goes wrong, our network or our application should actually continue operating. So how do you make your architecture or application fault tolerant? So this is where the need of this concept comes into play. And let us talk about some needs. So if we have to highlight some of the needs, number one thing would be fault isolation. So failure in one microservice should not lead to complete failure of entire application. So If one microservice fails, the failure should be restricted only to that microservice. And that is where this fault isolation comes into play. And this is one of the reasons why we need fault tolerance. Then network latency. So microservices communicate over a network, and there can be possibilities where there can be network failures, and there will be several issues wherein the network call might just not happen. And in that particular case, we need to take care of the network latency, and this could lead to failure. There could be deployment issues. So since microservices are deployed separately, so if you have 3 microservices, those 3 will be deployed separately as separate application. Now, because of deployment, there is a likelihood that there are some issues that I've encountered during the update of a microservice. And because of this, that particular microservice might be down for a little while. Now, this is where the problem comes in. So how do you handle such scenarios? So this is where fault tolerance also matters. Increased complexity. If there are several microservices in your architecture or your application, it could lead to increased complexity, and it could also lead to unforeseen failures which you cannot gauge as a developer. And this is where fault tolerance again is important. Lastly, we have elasticity, and then we have tolerating external failures. So elasticity talks about how well can microservices often scale independently based on demand. Okay. So if you make your microservices resilient enough, your microservices can scale easily without causing any disruptions. And then tolerating external failures. So in this particular case, microservices might interact with external services or APIs or databases. Like for example, I might be using Twitter API, or I might be using some API which allows me to convert a text to PDF or something like that. So it could be any external system that I am interacting with. And if that system goes down, then that microservice which is using that particular system will be impacted. And in this particular case, like, you need to handle these things gracefully. So these are the needs as to why fault tolerance becomes important when you're building a distributed system. It becomes really evident, like, you need a concept like this when you are building something as complex as microservices. So this is about fault tolerance and why something like fault tolerance matters when you're building something as complex as microservices. Welcome back. So let us start talking about Resilience4J, and we will also discuss Resilience4J modules, features, and we will even cover some techniques when it comes to adding resilience to your network. So before I talk about Resilience4J, I wanted to spend some time talking about what you mean by this word resilience. So what is resilience? Resilience is ability or capacity of something to recover quickly from difficulties. So when we talk about microservices, fault tolerance in our network is really important. So fault tolerance in our architecture makes sure that we are resilient enough to failures. And this is where the concept of resilience comes in. So resilience exists to add fault tolerance in our microservices architecture. And there are a few techniques, patterns that helps us deal with failures that happen in our system, because we need to ensure that our system can handle these failures gracefully. Of course, when you're building microservices, you cannot avoid failures. So not only microservices, when you're building any kind of systems, like, failures can just happen. It just comes with it. But the best part is you should be able to handle them gracefully. And this is where these techniques come in. So let us talk about some techniques there. So the number one technique is retries. So whenever you have a request to a microservice that fails due to some temporary issue, like, and the issue can be like network timeout or resources unavailable or something, what you can do is the client who is making the request can automatically retry the request a certain number of times. Okay, So if I make a request to microservice B, okay, and I am microservice A. So if B is down or there is some issue with B, now I made a call to microservice B and the call didn't went through. So I can decide to retry the request for a certain number of times. And these retries can help improve the chances of a successful request, especially when the failure rate is due to some temporary issues like network latency or something like that. So there is a possibility that if I do a second or a third retry, the microservice is up and running and my request is successful. So this is about retry, and this is one of the techniques that exist. So this way we have avoided the fault that would have happened in our network or our architecture, and we have made our system resilient. So this is one of the technique. Another technique I want to talk about is rate limiting. So what is rate limiting? So rate limiting controls the number of requests that a microservice can handle within a specific time frame. So it prevents the overload on the service and ensures that there is a fair usage of the resources within that microservice. So every microservice or every system that you have has a capacity, and rate limiting makes sure that the requests that are going to that particular microservice in a particular time frame matches the capacity and it does not overshoot the capacity. So rate limiting is useful for protecting against some excessive traffic or potential attacks like denial of service. Okay, so this is about rate limiting. You have bulkheads. So bulkhead is a pattern. It's about isolating different parts of the system to prevent a failure in one component from affecting others. And in microservices, this means dedicating a separate resource for different services. And if one service experiences high load or fails, it won't impact others. So this is bulkheads. Then you have a technique called circuit breakers. Now what is circuit breaker? So circuit breakers monitor the health of the microservices and they prevent the cascading failures. So if there are two microservices, let's say microservice A and microservice B, and if B fails, so because of the failure of B, it won't impact A. So if there is a request that is going to B, circuit breaker will make sure that it handles gracefully. Now how this is handled is when a service repeatedly fails or experiences high latency or something, the circuit breaker trips and the subsequent requests to that particular service are redirected to any fallback that you must have declared or the error response. Okay, and this avoids overloading a struggling service or provides a degraded but functional experience, and it makes sure that the application does not breaks. So this is about circuit breakers. Then you have fallbacks. Now what are fallbacks? So fallbacks are alternative actions or responses that are provided when a microservice is unavailable or it fails to just respond. Now fallbacks can be predefined. Okay, so you can have default values or like default responses from cache or some secondary data sources. And this way you can create fallbacks for your service. So fallbacks ensure that users receive some response even when the primary service is unavailable. And this helps prevent failures which would have occurred if fallbacks were not present. So this is one way of handling, or one technique of handling failures. Then you have timeouts. Now what are timeouts? So timeout is the amount of time a client who is making a request will wait for a response from a microservice. Okay, that is what timeout is. So if the service does not respond within the specific time period, the client can take the desired action, like which is defined, such as retrying the request or using any fallback. So alternative path can be anything depending on the microservice, but yeah, you can retry essentially, or you could have fallback or anything like that. So this is what timeout is. Then you have graceful degradation. Now what is this technique? So graceful degradation refers to the ability of a microservice to continue functioning with reduced functionality when facing issues or high load. So non-essential or resource-intensive features can be disabled or simplified to maintain essential services only. Okay, so this is what graceful degradation is, and this helps prevent failures and ultimately makes sure that our architecture is able to tolerate faults and ultimately makes our architecture resilient enough. Now, how do you implement all of this? So this is where we can talk about Resilience4J. So Resilience4J is a lightweight, easy to use fault tolerance library. Okay, because managing these patterns that we just spoke about can be a challenging task, and that is where Resilience4J comes in. So Resilience4J is a simple library which you can add to your project. It is very lightweight and has minimal dependencies and is specifically designed to be used with Spring Boot applications. So this is the best part. So Resilience4J also has key modules such as retry, circuit breaking, rate limiter, and so on. Okay. Now we discussed why it's a good choice. So it has easy integration with Spring Boot. So it has a starter library which you can add to your project and you are ready to go. Then it is built for functional programming paradigm. And this is a programming paradigm that is introduced in Java 8. And this makes this library great fit for modern applications. All right. So this is why it's a good choice. Now let us talk about some of the Resilience4J modules that I would like to introduce you all to. So the number one is the retry module. We have rate limiter, then we have bulkhead and circuit breaker. Let us talk about retry module. So it is not uncommon for a network call or a method invocation to fail temporarily, and this failure could be because of network glitches or any other issue. So rather than failing immediately, we might want to retry the operation a few times before giving up. And this is where retry module from Resilience4J comes into picture. So retry module enables to easily implement retry logic in our application. So you just need to do some configuration and add an annotation and you are good to go. Then we have rate limiter. So when we have a service that can handle only a certain number of requests per time period, so we need to ensure that we do not exceed that limit. Otherwise, the service will be overloaded and it will go down. And this is where rate limiter comes into picture, where rate limiter allows you to enforce these restrictions and protect our services from too many requests. Then you have bulkhead module. This module is based on bulkhead pattern and it isolates failures and prevents them from cascading through the system. Okay. So the idea here is to limit the amount of parallel executions or concurrent calls to prevent system resources from being exhausted. Then you have circuit breaker module. Now this module is used to prevent a network or a service failure from cascading to other services. So this way you can add resilience to your network. So if a circuit breaker trips or opens, then this particular module prevents the further call to that particular service. And ultimately it makes your architecture fault tolerant. So this is about Resilience4J, their modules, and some of the techniques that we have learned in this lecture. Hey, welcome back. So let us start talking about what is circuit breaking. So what I'm going to do is I'm going to head over to google.com in my browser and I'm going to search for Resilience4J. So Resilience4J. And the moment you Google this, I'll zoom in a bit. So you are going to see this first link, which is resilience4j.readme.io docs. So just hit this link and I'll visit this URL and you will see this documentation open up. Okay. So this is the official website of this particular library here. And you can read more about this particular library. Like it's a lightweight fault tolerance library designed for functional programming. Okay, so you have a lot of information here. You can just go through if you wish to. Okay, it talks about the core modules that this library has. And on the left hand side, you have a sidebar where you can see core modules like circuit breaker, bulkhead, rate limiter, retry, and so on. Okay. So you can just explore this website, but what we are going to talk about now is circuit breaker. So I'll just head over to the circuit breaker and you will see this link open up over here. Now you can see a diagram over here. So now what is circuit breaking? So circuit breaking is a mechanism that is used in microservices architecture to avoid cascading failures across multiple services because of that one service. Now, why is it called circuit breaker? Because it implements the mechanism that is similar to that of electrical systems. So in electrical system, you have a circuit that can be closed. So if it's closed, the electricity flows, and if it's open, the electricity stops flowing. Okay, and that is how this particular thing works. So here you can see there are different states. So you have closed state, open state, and half open state. So closed state meaning the system is healthy and there is nothing that has failed. Now what happens if anything fails? So if anything fails, there is a failure rate that is associated. So you can see failure rate happens, and then there is a threshold that is configured with this system. So if the failure rate goes above a particular threshold, the circuit moves from closed to open. So this means, like, this transition from closed to open means that something is wrong in the system, and the subsequent calls to that particular microservice won't be done because there is an issue. So what I mean over here is, let's say you have microservices A and microservice B. And if A is making call to B, and let's say B is down, and if there are like multiple failures which are above the threshold, then all the calls to the microservice B won't happen because the circuit would move to open state. Okay. And that is what circuit breaker is. So now it's moved to open. Now, how does it move back to closed, and how are we permitting calls then? So if it's in open, there is a wait duration. So you can see over here after wait duration. So there is this wait duration for which it stays in the open state. And after wait duration is done, the circuit breaker then moves to half open. Now, what does half open mean? So in half open state, a certain number of calls are allowed. So a limited number of calls are allowed to pass through the circuit. So what this means is, if I was making call from microservice A to B and the circuit moved to open state, now after certain wait time, it moved to like half open, and in half open state, if my system is configured to permit 3 requests in half open state, so only 3 requests will be permitted to that of microservice B. And because these 3 requests are permitted, system gets a chance to understand if this particular microservice B is back up again. And if it's back again, what happens is the circuit breaker state then moves from half open to closed state. So here you can see failure rate below threshold. So if it's back up again, the failure rate drops to a value below threshold, and then the circuit changes back to closed. So essentially how this works is, if there is a failure in a microservice, there is a circuit breaker that exists which makes sure that the call is not sent to the microservice which has failed. So it controls essentially the failure, and it makes sure that failure is contained to that particular microservice only and not a system as a whole. So that is what circuit breaker is, and this is how the circuit breaker works. So this diagram is really important, and it demonstrates how the states transition depending on what happens in the system. Okay, so this is about circuit breaker. Hey there, welcome back. So let us start talking about how can you integrate Resilience4J with Spring Boot. So to do that, I'll head over to our favorite website, which is Spring Initializer, and I'll select Maven here, and I'll click on Add Dependencies, and I'll say Resilience4J over here. So you can see this dependency come up, and you can hit explore. So you will see this particular dependency has been added. So this is a dependency to implement circuit breaker into your application, as you can see. So I'll copy this and we will head over to our project. So now in this project, what I'm going to do is I'm going to add this particular configuration that I have copied to pom.xml of jobs. So I'll go to the dependency tab and I'll paste the thing that I have copied. Now here, I'll add one more dependency. So I'll say dependency and I'll say group ID is org.springframework.boot. So I'll select this. And here, okay, so it got populated. So Maven plugin got auto populated. So I'll just remove this and I'll say Spring Boot Starter and I'll get AOP. So I'm adding this dependency to add a support for aspect oriented programming. Okay, so I've added this and yeah, everything looks okay. Now I'll hit reload Maven changes. And this should resolve all the dependencies and your application should be up. So what we have done is we have configured Resilience4J to work with job microservice. And in the subsequent lectures, we will start implementing its working. Hey there, welcome back. So let us start configuring the circuit breaker into our application. So what are we going to build actually is we have multiple microservices. So we have job microservice communicate to company microservice, and it does so via the controller. So here, if you go over here, so not in controller actually, we should go in the implementation class here, and here you can see we are calling the company service here. Okay, so here if you go to map company with TTO, we are mapping the company objects and we are calling the company as well as reviews, in fact, using this method call over here. And this is with the help of company client. So job microservice is interacting with company microservice. So we are going to implement a circuit breaker with job and company for this particular communication. All right. Now, what are we going to begin with is we are going to begin starting our microservices. So just make sure your microservices are all up and running. You should also see the status of all the instances over here. Now, let us try accessing the actuator. So I would want you all to go to the job microservice, select pom.xml and make sure that the dependency for actuator is added here. And this is because we will be using it to monitor the health. So if you go to job microservice here, we will go to localhost, we will say 8082 and I'll say actuator. Now here if you go, you will see the health endpoint that has been enabled. So I'll just open this health endpoint. Now you're not seeing much of the information about health. So we need to enable the detailed health information, which will enable us to get different application metrics. So let us head over to our IntelliJ IDEA project and I'll switch over to application.properties here for job microservice. And I'll scroll down here and I'll add a comment here. I'll say actuator. Okay. And I'm going to add some actuator configuration. So I'm going to say management.health. Sorry, not health. I'll say management.endpoints.web.exposure.include is equal to health. Okay. And then I'm going to copy the same thing here. And instead of web exposure, I'm going to just say health
dot show details, and I'm going to add always over here. So what these two property does is this is exposing the health endpoint in the actuator, and this is adding a lot more details to this particular endpoint. And the reason for this is we want to show much more information about our application health, like how many number of requests are happening, how many are failings, and so on. Okay. So we will be using these metrics to monitor as to what is happening with our microservice. Okay. And we'll be understanding whether circuit breaker is actually working. Okay. So I'll head over here. So without those configurations, we had only up. Okay. Okay, we have not restarted the microservice. So what I need to do is I need to select job and I need to say rerun over here. So, okay, so the microservice is restarting. So we'll wait until it restarts and we'll check the status here in Eureka. So the job service is up and running. Now let us head over to actuator/health and let us see if detailed information has come up. So I'll hit refresh. Okay, so we are not getting the detailed information. It still says status up. Let us see what mistake we are making here. Okay, so I should remove S from here. So it is management.endpoint.health.show-details. So this was a mistake. There was a S over here, which I removed. And I'll rerun this application. So just make sure if you're adding this, you don't have any typos. Okay. Because if you have any typos, it won't work as expected. So just be sure of that. Now I'll head over to my browser and let us hit refresh. Okay. So the refresh is done and you can see the detailed information about your application now. All right. Now, what we need to do is we have the actuator health endpoint enabled, and this health endpoint will enable us to see the circuit breaker details as well. All right. And that is the reason why we have enabled this. So now we need to start configuring our circuit breaker. So in order to configure the circuit breaker, what I'm going to do is I'm going to add few configurations into my application.properties. And I actually have these configurations added here in this notepad, which I'm just going to copy. So I'll copy all of this for Resilience4J. Okay. And I'll get it pasted over here. All right. And I'm also going to copy this part. Okay. So this is the actuator configuration. So these 2 points we have already added. Okay. And this is the third one. And we'll go through what each thing means. But for now, I'll just copy this in the end. Okay. And I'm going to go to right here and I'll say here. Now I'll remove these two, which we had added previously. All right. Now let us understand what this means. Okay. So there is a meaning in everything and every property means something on the other. So here what we are doing is we are specifying some configuration to create a circuit breaker. So this property says register health indicator. All right. But first of all, we are creating a circuit breaker with the name company breaker here. Okay. This is a name. So when we say company breaker dot register health indicator is equal to true. So this property registers a health indicator for company breaker circuit breaker. Okay. So company breaker is the circuit breaker instance that we are creating here. So you can see circuit breaker dot instances dot company breaker. So this is the instance that is being created and it is being registered in the health indicator. And this can be accessed via the health endpoint, which we have enabled over here. All right. So this is the reason why we enabled health endpoint. Now the next property says sliding window size. So sliding window size defines the number of calls stored in the sliding window of the circuit breaker. And this is used generally to calculate the percentage or failure rate. All right. So we have kept it to 10. Then we have minimum number of calls. So we are saying minimum number of calls as 5. And this defines the number of calls that can be recorded before the circuit breaker can calculate the failure rate. Okay. So to calculate a failure rate, we need some calls, right? We cannot calculate failure rate on 0 calls. So that is what this number defines. So we can customize this as per our requirement. So this is one. Then we have permitted number of calls in half open state, and we have set that to 3. So the circuit breaker can go in open, closed, and half open state. Now, half open state is a state where you can permit some number of calls before circuit breaker can decide to transition back to open or closed state. All right. So half open is a state in between, and essentially you are configuring the number of calls that can be permitted in that particular state. So we have mentioned 3 over here. You can customize this as per your requirements, but for learning purpose, we have set it to 3. Then we have wait duration in open state. So this property determines or controls how long the circuit breaker should stay in open state. Okay. So in open state, the calls that are being sent to the microservice are rejected. Okay. And we have specified this to 10 seconds. Then we have failure rate threshold. So this defines the threshold when exceeded, the circuit breaker will transition to open. Okay. So here we are saying 50, which tells that if the failure rate is more than 50%, the circuit breaker will transition to the open state. All right. Then we have register health indicator is equal to true. So this property is similar to the first property that we have set. Okay. So it will register the health indicator into the actuator or the health endpoint. Then we have automatic sliding transition from open to half open enabled. So this property enables circuit breaker to automatically transition from open to half open state. Okay. And then we have the sliding window type. Okay. So this determines the type of sliding window, and we are saying that we want count based, which means that the last n calls are recorded and they are used to calculate the failure rate, where n is the size of the sliding window. Okay, so this is just the window type that we have determined. So these are some properties that we have added, and you can also add this one more property here, which we have added to the actuator configuration, which says circuit breakers enabled true in health. Now what this means is this will enable the health check for circuit breakers in the actuator. All right. So these are the configurations. Now, if you head over to browser and if you go to the Resilience4J documentation, if you click on circuit breaker here on the right hand side, you're going to see create and configure the circuit breaker. And if you click on this, you will see this table here. And this is all the table that has all the configuration that you can define. So you can see over here, failure rate threshold. It has the default value as well and the description as to what this does. So if you want to customize anything, you can customize over here. So you can see here, sliding window type is count based. You can even set it as time based. Okay. And you have different number of properties. So you can go through this if you wish to. So this is for additional exploration. But now what we have done is we have configured the application.properties. Now let us create the circuit breaker. So what I'm going to do is I'm going to head over to the controller here. Not controller. So we will need to implement this in the service implementation class. So what we are going to do is we are going to go to get all jobs. So this is the method which helps us get all the jobs from the database. All right. And this is the one that maps it to DTOs. So what I'm going to do is I'm going to add an annotation over here to this method, and I'm going to say circuit breaker here. Okay. And here I'm going to say name, and the name will be company breaker, like so. So this is the same name that we have added in the applications.properties. Okay, so not this one, but this one, which is for jobs. So this is the name that we are adding over here. Okay, so yeah. So what we are saying is circuit breaker is to be enabled on this particular method here. And this is a method that enables us to get the list of all the jobs. Okay. And if you scroll up here, you can see from where this annotation is coming in. So this is coming in from Resilience4J circuit breaker dot annotation. And this we are getting because we have added the dependency. So this is about the configuration and creation of circuit breaker in our job application. Welcome back. So let us see the changes we have done in action. So we have added a circuit breaker into our application for getting all jobs method here. And we have also done a lot of configuration in our application.properties. So if you have not restarted your application, I would request you to go to Services tab and rerun your job application so that you can get these changes to effect. Now let us go to our browser and let us see all these changes. So here in browser, I will access the actuator/health and I will hit refresh over here. Now the moment you hit refresh, you are going to see under components, you're going to see this tag here, which says circuit breakers. You'll see status up and you'll see company breaker, which we have just created in our application. Along with this, you are going to see some details of this. So here you have different properties like failure rate. Now what is failure rate? Failure rate is the percentage of recent calls that have failed. And if you have this negative value like -1 or something like I am seeing, this indicates that there have not been enough calls yet to calculate a meaningful value. And this is because we have just restarted the service. Then we have failure rate threshold. So this is the percentage of failures at which circuit breaker will switch from closed to open state. And in this case, if the value is more than 50%, it will fail or it will open. Then you have slow call rate, which says the percentage of recent calls that were slower than the configured threshold. Now again, negative means there has not been enough data to calculate yet. Slow call rate threshold, so this is 100%, and this is the percentage of slow calls at which circuit breaker will switch from closed to open. Then we have buffered calls, and this dictates the total number of calls that the circuit breaker has recorded in its ring buffer. And this includes the total number of calls like the successful as well as failed. Then you have slow calls, which keeps a track of slow calls that have happened. Failed calls, so these are slow failed calls. So these are calls that have been slow as well as they have failed. So slow as in they have been slower than the configured threshold. Then we have failed calls and not permitted calls. So failed calls are the total number of calls that have failed. And then we have not permitted calls. So if the circuit breaker is open, then the calls won't go through, right? Because circuit breaker will reject. So this is that number. So total number of calls that have not been permitted. And then finally, you have the state of the circuit breaker. So this can be closed, open, or half open, depending on the time you are accessing it. So this is our circuit breaker details that we have, and we will be using the actuator health endpoint to monitor this. Now we have all our services up and running here. So if you head over to Postman, and if I go to job microservice, so we have to go to 8082 port and let us try getting all the jobs. So if I send this request, I get an empty call. So let me create a few jobs. And before that, I'll create a company. I'll create a review here against that company so that we have some data to work with. And then I'll create a job as well. Now, if I try to fetch jobs, I'll see like the details of the job along with company and review. Now, if I come back here and if I access health endpoint, you will see there have been 2 calls that have happened. Okay. And you can see there are 0 calls that have not been permitted. And that is because the state of the circuit is closed. All right. Now let us make our company service go down. Okay. So the circuit breaker is between the job microservice and the company microservice. So if the company microservice goes down and if our failure rate happens to be higher than that of threshold, the state should change to open. So let us try that. So I'll head over here to IntelliJ and I'll turn down the company microservice. Okay. So the microservice is down and it's removed from Eureka registry. Okay. Now let me do a API call. So I did one call. So of course this is failing. And if I refresh our endpoint, you will see buffered calls 3 and failed calls 1. Okay. Now let us send this request again for some time. Okay. So I have done like 5-6 calls now. And if I refresh, you will see failure rate is 60, state is open, and failure rate threshold is 50%, which we had set. Okay. So circuit state is open. Now if I refresh, it goes to half open state after 10 seconds because that is what we have configured in our application. Okay. So this is now half open and let me do a call now. So if I do a call, it won't go through. If I do one more, it won't go through. Let us also check the logs here. Okay. So if I refresh this, it's still in half open. And if I check logs here, so job microservice. So here for job microservice, if you scroll up here, you will see an exception here. So here in the logs of job microservice, you can search for call not permitted exception. Okay, so if you can say Control F if you're on Windows and Command F if you're on Mac, and you can enter this call not. So if you just enter call not, you will find this call not permitted exception. So what happens is whenever the call is not going through or the circuit is open, then you get this exception over here because call is not permitted because the circuit is open, and you can see the reason also over here. Okay. Now what we will do is we will turn back our company microservice up again. So let's say company microservice was down for a while. There were some issues with the microservice and developers worked hard to fix this and bring this service up. Now you will see if I refresh, this is still half open, which means there will be certain number of calls that will go through the circuit. So if I send this request again, it gives me error. If I send this again, okay, it will give me error because there is no company there now. So I'll create a company and I'll try getting the response. So I'll say get, and this works now. So if I come back here and if I refresh, you will see failed calls have become 0 now, like in recent duration. Buffered calls 1 and state is still half open. So this will go to close state after some time, after we have some X number of successful calls. So I did one successful call. I'll make a couple of them and I'll come back and I'll hit refresh over here. So you will see there have been now certain number of successful calls, and that is the reason the state is now changed to close, because the circuit breaker now assumes that the service is back up since the calls have been successful, and that is why it's allowing now all the calls. So this is how the entire process of circuit breaker works. Okay, so you can see how different parameters were working when a particular service was down, and how our configuration also gave us a better control to configure different options here. So you have multiple options here. You can change anything. Like you can even change the wait duration if you want wait duration to be higher or lower. Okay, you can have minimum number of calls configured and so on. So you can play around with these settings a bit, and depending on the use case, you can get this applied to your production applications. So this is about circuit breaker in action. All right. I hope you all enjoyed this class and found it valuable. I shall see you all soon. Thank you. Welcome back. So let us start talking about the fallback mechanism. So here, whenever a microservice is down, like when our company microservice was down, and if we tried sending a request, we got an error over here. Okay, and circuit was set to open. But it's not a good thing to show an error to the user. So let me simulate this scenario again for you. So I'll stop the company microservice and I'll try sending in this request. So you can see we are getting an internal server error for jobs. Okay. And here the circuit will be open. All right. So this over here is not a good thing. So you're showing errors to your users. So you can easily prevent this or control this by using something called as a fallback mechanism. Now, what is a fallback mechanism? So fallback mechanism is an alternate path that you have to show to the user whenever there is a failure of an microservice. And you can implement this with the help of circuit breaker. So let us head over to IntelliJ and let us implement the same for this scenario here. So here in IntelliJ, I'm going to head over to circuit breaker over here. Now here we have passed one parameter, which is name. I can pass one more and I can call that parameter as fallback method. Now here I can define a fallback method. So I can say company breaker fallback. So I can have this definition created over here. Now what I can do is I will have to define this particular method. Okay, so I'll copy this method name. I'll go over here and here I'm going to say public. And let's say I just want to return a simple list of string values and the method name is this. Okay. Now I'll have, let's say I'll have some code defined over here. So I'm just returning the list of a simple string as a fallback over here. So I'll say list string and here I'll say L list is equal to new array list. And now I'm going to say L dot add. I'll add just some dummy information. So I'll call it dummy and I'll return L or I'll return list. So this is the implementation here. All right. Now this will also have a parameter exception E, okay, which we have added. So this is the fallback method that we have created. Now one thing to keep in mind is to keep this names similar. Okay, so just make sure that this name that you have specified here in with the annotation as the parameter matches the name of the actual method. All right, this is where a lot of people go wrong and then it does not work. So I'll restart my job microservice and let us see what the output looks like. So our job microservice is up and running. State is closed. Now let me hit the URL over here. So just for your information, the company microservice is still down. So I'll say send. So we don't have any jobs. So we need to create a job in order for a request to go to the company ID. So I'll say send. And now here, since the company microservice is down, we are saying dummy over here. Okay. And this is a message that we have given in the list. So this is the list that we are getting over here. Okay. So here we are clearly not getting any error. And if you send this like 4-5 times, and if you head over to this particular endpoint, you will see failed calls 4, not permitted calls 2, and the state is open. So not permitted calls is 2 because 2 calls were not permitted because the circuit state changed to open after repeated failures. But the best part is this over here, you're not seeing any errors. So if there is a failure and if you want to handle failure gracefully in front of the users, you can have some dummy response created, or you can have some alternative database or something from where you fetch in some information and give it to the user, so that at least the request loop is closed and user does not see any error messages. All right. So this is the benefit of adding fallback. And if you go back to IntelliJ, you will also see we are not getting any errors here. Okay. So this is about the fallback method and how you can get this implemented into your microservices along with circuit breaking. Welcome back. So let us implement the retry mechanism with the help of Resilience4J. So we have already seen how circuit breaking works, and Resilience4J also provides one more way or one more technique called retry with the help of its retry module. So we will be implementing that, and retries are simple yet effective way to add resiliency into our system. So what is retry? If any network call fails, we will be retrying that network call to see if we can succeed. And we can do all the configuration as to how many times we want to retry and what should be the duration and so on. So to begin with, what I'm going to do is I'm going to just comment this out here. Okay, so I'll select this and I'll comment this out. Now I'm going to add a new annotation over here and I'm going to say retry here, like so. And if you scroll up here, you will see this is also coming in from Resilience4J library that we have configured. Now we need to add the details. So here I can say name is equal to, so I'll say company breaker. So we'll add these similar details here. Okay, I'll just paste it over here. Okay, and this should work. So let me remove this comment from here. So yeah, retry is configured for this particular method here. Now I want to demonstrate how retry works. So what I'm going to do is I'm going to create a temporary variable over here. I'll say integer attempt and I'll initialize this to 0. Now I'm keeping this variable over here, or I'm creating this variable to keep a track of all the retries that are happening. All right. So what I'm going to do is I'm going to say over here system.out.println and I'm going to say attempt and I'm going to say attempt. Okay. And I'm going to increase the value of attempt. So for every method call here we do, the attempt value will increase and it will print the same onto the system. So we have implemented the retry functionality. Now let us head over to our application.properties and let us do some configuration over here. All right. So here I'm going to say, so since this is the configuration for Resilience4J, I'm going to come here and I'm going to copy this entire thing. Okay. And I'm going to say instances.companybreaker.max attempts. All right, and I'll delete all of this and I'll remove all of this, the rest of the part, and I'll say max attempts can be 5. So here I'm configuring the maximum number of attempts that we will be doing if the network calls fails. So I'm mentioning this to 5. Now I'll copy this and I'll paste it over here and I'll add one more thing over here, which is the wait duration. So I'll say wait duration, like so. And I can say wait duration as 2 seconds. So wait duration specifies the duration for which we will wait before making the next call. And max attempt is the number of attempts that we will do. So now I'll restart this service here. Okay. Now let me restart the job microservice. So after starting the job microservice, just check whether the service is up in Eureka. Also, I have the company server down. Now what I'm going to do is I'm going to head over to Postman. I'll create a job and I'll do a request to fetch the job. Okay, so something happened here. The request is not loading. So I'll just close everything and I'll just select this. Now I'll try getting the job. So when we trigger the request now, we got a dummy response. All right. Now let us head over to IntelliJ and see what the output looks like. So here in IntelliJ, I'm checking the logs for job application. And now here, if I say attempts, so you can see attempt 1, attempt 2, So you can see attempts happening for the request over here, and the application is trying to fetch the data from the company microservice. All right. So retry module is indeed working now, and we are seeing our changes based on this particular configuration. All right. So this is about the retry module and how you can get this implemented into your project. Hey there, welcome back. So let us start talking about rate limiting. What is it and why is it needed in modern web applications? So what is rate limiting? So rate limiting is a technique for limiting any network's traffic. So it sets a limit on how many requests a client can make to a server in a specified amount of time. So in other words, it's a way of controlling the rate at which an application or a system uses resources. Okay. So this is what rate limiting is. Now, if I have to give you an example would be an API might have a limit of 1000 requests per hour. And if you exceed this rate, the server would return a response, which is like something like 429. And this response with status code of 429 stands for too many requests. So a website might have a rate limit for account creation to prevent some spam accounts being created, and you can only create one account every 10 minutes from a single IP address. So if this rate is being exceeded, it's likely that there are fake accounts or some spam accounts being created. So these are some of the examples as to where rate limiting can be used. Now, what is the importance of rate limiting? So rate limiting can be crucial for several reasons. So the number one reason could be preventing abuse. So without rate limiting, a malicious user can overload a server with requests, causing it to slow down or crash. So this is one of the reasons as to why rate limiting is important. Resource allocation. So by limiting the number of requests, you can ensure that resources are distributed fairly amongst all users. Cost management. So if your server or API is hosted in cloud and you pay for the amount of traffic it handles, rate limiting can help you keep costs under control. These are few points as to why rate limiting would be important in today's applications. Now, what are the use cases of rate limiting? So the number one use case is of APIs. So in API world, to prevent a single user from making too many requests, APIs often use rate limiting. So this protects the server from unwanted load and ensures fair usage. Web scraping. So there is a possibility that people might be doing web scraping onto your website. So sites might use rate limiting to prevent web scrapers from overloading their servers. Login attempts. So to prevent brute force attack, websites often limit the number of login attempts from a single IP address. So you must have seen this message that maximum number of login attempts exceeded and retry after like 5 minutes. So that is rate limiting in action. So if there are maximum number of failed login attempts from a single IP, then a website might block requests from that IP for a certain period of time. And this is to secure the website and your account. So these are some of the use cases of rate limiting. Now, there have been some real world incidents of DOS. So what I mean by DOS is denial of service. And DDoS stands for distributed denial of service attacks. So distributed denial of service attacks are where multiple systems flood the bandwidth of a particular system and they try to take it down. Okay, so you will have one server that you are targeting and you will target that one server from multiple places. So there is no single IP from where the request is coming. It is coming from multiple servers. And one of the most notorious attacks that has been of this type has been with GitHub in 2018. So they have even written a blog post on this. So here in browser, if you search for like GitHub DDoS, so you will land on this link here and you can see this happened on February 28th and they have acknowledged that this is something that happened. Okay. due to distributed denial of service attack. And they have also given as to what happened exactly and why this incident occurred. So you can see the server load went suddenly up. You can see over here, and they have posted everything. So yeah, so this is about a real world example. Okay, and GitHub was hit with a massive attack, and this attack took GitHub down for some time. All right, so GitHub was not working, so they have mentioned it over here. GitHub was unavailable for this much of time. Okay, so this is about the real world incidents of denial of service attacks. So now the question is, how can we build resilience into our applications to prevent these kind of things? So you can do this with rate limiting feature of Resilience4J. So Resilience4J is a lightweight library, and you can use the rate limiter module as to control to how many times a method or a client can call your service in a given period of time. And this is really useful in microservices architecture, where you need to control the number of calls to prevent your service from being overwhelmed. So this is about rate limiting, and I hope you have a fair understanding of this concept now. Welcome back. So let us start implementing the rate limiter module. So since we have Resilience4J configured into our project, Resilience4J has a module called rate limiter, as you can see over here on the left hand side. So you can click on this and you can read more about rate limiter and how rate limiter works. Now if you scroll down here, you will see this table here under create and configure rate limiter. So this table gives you the configuration that you can add in your application.properties or within your application to get rate limiter configured. So you can see timeout duration, and the default value is 5 seconds. And this is a default wait time a thread waits for a permission. You have limit refresh and then limit for period. So this is the 50. So limit for period means the number of permissions or number of calls that are allowed during one limit refresh period. So there are 50 calls that are allowed for now. Okay. So let us head over to our application and let us start configuring this. So here in IntelliJ, I'm going to paste some values here, okay, for rate limiter, which I have already written. So these are the values. So I'm saying Resilience4J dot rate limiter, and I'm saying instances, company breaker, timeout duration, I'm specifying as 0. Okay. So this is the default wait time a thread will wait to acquire permission to run when the limit is reached. So I'm setting it to 0. Then I have limit refresh period. So limit refresh period is the period after which the limit is refreshed, and you have the limit for period set to 2. So what this means is the rate limiter will allow 2 calls every 4 seconds for us. Now if more calls are made within that period, they will be immediately rejected without waiting. Now why without waiting? Because the timeout duration we have specified is set to 0. So if we specify the timeout 0 to 5 seconds or 2 seconds, it means that the more calls, if they are made within this period, they won't be immediately rejected, but they will be made to wait for that particular duration. All right. So this is our configuration. And what I will do over here is I'll now head over to services, and I'll now restart my job application. So our application is started now. Now we'll head over to our browser, and now we need to simulate this scenario. So we need to have a way to simulate these many requests to our server. And for that, we are going to make use of a tool called JMeter. I'm just going to search for JMeter. Okay. So JMeter is nothing but a load testing tool for analyzing and measuring the performance of variety of services. So with the help of JMeter, you can simulate a lot of requests on your application or on any endpoints. So you can go to Apache JMeter and you can say download, and you can download the zip file from here. So I have downloaded the Apache JMeter here. And now what I can do is I can head over to the unzipped version. So after downloading the zip, you can unzip it, and here in bin folder, you will see this file apache jmeter.jar, which you need to launch. So it will take some time to launch for the first time, but then it will open a window like this. Okay. So here now we can right click on this test plan on the left hand side, and we can say add a thread group. Okay. Now we can specify a number of 5 over here in the number of threads, and we will save this. So I'll just minimize this. So thread group is created. Now I'll say right click on thread group and I'll say sampler HTTP request. Okay. Now here is where we will be simulating this request. So what I'm going to do is I'm going to head over here and I'm going to copy 8082. So here I'm going to enter the details. So I'm going to say HTTP. Server name is localhost. Port number is 8082. And then we will have to enter the path. So I'm going to go to Postman and I'm going to copy /jobs here. And I'll say jobs here. And I'll make sure that the request type is get here. Okay. So this is done. Now I'll say add. Now once you have created this, you will see this start button over here at the top. So just click on this green button and it will say you should save this particular thing. So just save this by clicking on yes. So you can save it with any name. Now after you have saved, you can click on this request. You can say add and you can go to listener. Now here you can see view results tree. So now here we can run this and we'll see all the results. So you can see all the requests are being sent right now. Okay. And nothing seems to be failing. So all the requests worked properly and none of the requests were blocked. So here you're seeing green requests, meaning all worked properly. So we are missing something. So we'll head over to our source code and here we have configured properties. But if you go to the service implementation, we also need to add an annotation over here. So what I will do is I'll disable this annotation and I'll say @ rate limiter. So this is something that we missed. Okay. And I'm going to copy this same information here. Okay. So we have rate limiter named company breaker, and that is what the name that we have specified over here, company breaker. And I have added a fallback method as well. Now let us redeploy our application. So what I'm going to do is I'm going to rerun the job application. So the application is running successfully. Now if we can head over to the Apache JMeter and I can right click on this view results tree and say clear. So this will clear everything and then I can run this again. So now if I run, I'm still not getting the desired result. So if I change the number of threads to 10 and if I run this. Okay, so if you select the request here, okay, you will see sampler result over here. And if you select the request tab, you will see the request that is being sent. And here you will see the response that is being sent. That is being received, I'm sorry. So you can select 2 of the requests and you will see this response. But if you select the third, you will see dummy over here. Okay. Which means that after second request, the request is not being entertained and the fallback method is being shown. All right. Now if I remove the fallback, so if I go over here and if I go to implementation here and if I remove the fallback, let's say, for example, okay. And if I save this and I'll restart the service. So let us see what happens if you remove the fallback. So in this particular case, the request was working. It was not showing it over here. So everything was green, but it was shown in the response data. All right. So I believe the service is up and running. So we'll create a company and we'll create a job and let us see if it's working. So it's working fine. Now we'll go to rate limiter and I'll clear the results and I'll run the rate limiter again. Okay. So now this time let us see what happens. So again you're getting dummy despite removing the fallback. So here what you can do is you can select any request here. You'll see the sampler results. You can go to request and then response data. So here you will see the response that you're getting from the request. So you can select 1, 2, and if you select third one, you will get dummy as the response, which means this is not working and it is being returned. All right. So this is rate limiter in action.